Hey everyone, welcome back to another Logs.io training session. In this video, we're going to discuss how to query metrics in Logs.io using PromQL. Now, if you're new to Prometheus and PromQL, don't worry, I will be taking you from a beginner to an expert in just a short amount of time. So with that being said, let's jump right in. So the first thing we're going to do when we log into Logs.io to start querying is go into the Metrics tab in the left-hand navigation menu and click on the Explore page. Now the Explore page is going to give us the ability to not only query for metrics, but see everything that's going on within our environment or our Logs.io metrics account. In the top right-hand corner, you can see we can query for the last 1 hour or even the last 15 minutes or 30 minutes, so forth. We can also add these queries to a dashboard or split this directly in case we do have multiple metrics accounts in Logs.io we want to query across. Now let's take a step back and look at a specific metric. So in the metrics browser, you can see that I have the container CPU usage seconds total. If we look at this metric by clicking on the use query, you're going to see that we get a lot of data in our graph, but we also get a table. So the first thing to note about PromQL and Prometheus is we have instant vectors, range vectors. These are two important data types that we use when calculating functions and using functions in Prometheus. So you can see here that 12:20 at 9:59 a.m., we are getting an instant vector being a data point at a point in time. So at 9:59, we might get 1, we might get 5, we might get 3. That's going to be an instant vector. A range vector is a little bit different, right? Because a range vector is looking over a window of time. So if we're going to write a range vector, for example, we're going to have to pass a rate interval or a time window that we're searching across. So in this case, if we're going to write something that is going to be a range vector, we're going to be looking at something like over the last 5 minutes, for example. Now, there are specific functions that we're going to use when it comes to counters or gauges, which is the most common, and we're going to actually break down 2 use cases. So in that case, let's talk about what a metric is and what labels are. So if we look at container CPU usage seconds total, essentially this is going to be what the metric name is, right? So under the underscore name, that's our metric name. Everything else associated with this metric is what's called a label. And this is what we can aggregate by to get more data that's granular and useful to us. So for example, let's say we want to look at a specific pod that has our container CPU usage seconds total, right? We can write a query that looks at specific pods. Now, maybe we have a pod we want to look at specifically, or we want to look at a set of them. So maybe we want to write a regex search that says, give us all the OpenTelemetry pods in my cluster. What we can do is we can say pod equals, and then tilde, and then say OpenTelemetry dot plus sign. When we run this query, what you're going to see now is we only get the pods starting with OpenTelemetry, or prefixed by OpenTelemetry, right? We're not going to get anything else. Now, if we wanted to do an exact value match, we could emit the tilde, and then we could actually look at a specific pod. So if we, for example, want to look at OpenTelemetry demo accounting service, we would replace this value here, and then run this query. Sorry, I have 2 O's. So now we can see that this is going to give us the CPU usage seconds total. Now, what if we don't want to look at this specific pod? We can actually use a exclamation point equals, and now what we're going to see is every pod besides this. If we want to do a not regex, right, we can add the tilde, emit the equal sign, and then say, give me everything but the accounting service. By using the dot plus, now we're going to get everything besides that, right? So labels are essentially what we use to aggregate metrics. We have operators that we can use to add scalar values. So if we wanted to add +1 to this, for example, we can do that because Prometheus also kind of works like a calculator, right? We can do division, we can do addition, we can do subtraction, we can do modulos, we can do exponents, and so forth. However, on top of that, we start to get into functions. So we covered what a rate vector is, we covered what an instant vector is, we covered what a scalar is. We covered operators, which is the plus minus multiplication, which we are going to see in a use case that I build out. Now let's talk about functions, right? So functions have default arguments. Like I said, we covered instant vectors and range vectors. That's what we're going to be passing into our functions. And how essentially you write a function in PromQL is by wrapping a metric name around a specific function. Now, if we look at examples or if we look at functions in the Prometheus docs, you can see everything on the right-hand side is accessible in terms of functions. So if, for example, we want to look at the delta, we're going to say, okay, we're going to wrap delta, and then we're going to have to pass a metric. We can even pass labels if we want, but we're also going to have to pass a rate interval or a range vector. And you can see that here. So you can see that this gives a description of it calculates the difference between the first and the last value of each time series element in a range vector. So from the first to the last point over a 2-hour period, it's going to calculate that delta. Awesome. So let's take a look at this. If we want to write this in PromQL, we can say delta, and then maybe we don't want to look at this pod, and we want to say give us a delta over an hour. We passed our range vector, or our rate interval, and now we're going to get the delta, right? So in this case, we're seeing that there is a 40-second, about a 37.4-second CPU usage delta over an hour from the beginning to the end, right? So that is what a sample function would look like. However, what if we want to build out a specific use case? Where do you go to find these functions? The great news is if you're under the Kubernetes use case, Logs.io creates out-of-the-box dashboards that kind of gives you all this data at face value, so you don't have to build them out yourself. So if we want to look at pod stats here, you can see that it gives us everything we need, right? The amount of restarts, the phase, the amount of CPU usage, the utilization, the memory utilization. But what if I want to write these from scratch? Maybe I don't know it. Maybe my metrics will look a little different so they wouldn't aggregate in this view. What I can do is I can actually think about how I want to calculate these. So let's look at two different use cases, CPU percentage and then memory utilization percentage, right? Two saturation metrics. However, they're two different kinds of metrics. So if we were looking at something like the CPU utilization, you would see that the function kind of looks like this, right? So if we break this down, we're calculating the sum of rate over a 5-minute period, and we're aggregating by the label pod, or grouping by the label of pod. Then we're dividing that by the total pod resource limits. So if we run this query, what you're going to see is we're going to get our utilization percentage, but we're getting it in a fraction because we're dividing. But if we want to calculate a percentage, we multiply that by 100, right? Run this query. You can see now this is going to convert to something a little bit more readable. And then since we're grouping by our pod here, you can see now that we're getting our aggregation. So we're calculating the actual percentage value per the pod, which is good, right? So essentially what we're doing here, if we look at this from a metrics perspective, we're getting the container CPU usage seconds total, which is giving us the sum of that. And then we're dividing it by the total resources. So we're getting a ratio there and then multiplying it by 100. We have to make sure, however, that we are passing the resource of CPU, because if we instead, let's say we wanted to calculate the memory, what we actually would do here is change the resource to memory because that's a label that's coming through to differentiate them. And then we're also going to have to change the container CPU usage seconds total, right? Because that is not actually a metric to calculate memory. That's quite a CPU. So we'll change it to container memory usage bytes. Now let's run this query. Now it may look like, oh, we're getting the right data, right? However, what's important to note here is we're using rate for a gauge metric. Now let's think about this. If we're looking at the container CPU usage seconds total, which we were just looking at, right? That is a calculation of time. So as time passes, this is going to always be increasing and maybe there's a reset. So maybe the CPU crashes and now it's going to restart from 0. But it's always going to be increasing, relatively speaking, right? And that's what a counter metric is. So that's when we would use something like rate. However, container memory usage bytes is going to be what's called a gauge. And a gauge goes up and down and has a little bit of volatility to it. So it could go from 1 to 5, down to 3, up to 4, up to 7, down to 0, right? So that is when we don't want to use a rate function. So what I'm actually going to do here is omit the rate. I'm going to get rid of our rate interval, and then I'm just going to do a calculation based on the container memory usage bytes. So now I run this query, and I get more of an accurate memory utilization percentage. So essentially what I'm doing is I'm getting the correct metrics now because of the way I modified my calculation. And this is why you have to be aware of which kind of metric you're calculating for. Now, if this was, for example, a histogram and I wanted to get the quantile or a percentile value, right, I would want to use a different function. I wouldn't want to use the sum in the rates, right? I would want to use something like a histogram. So if I look up histogram quantile, for example, you can see it gives me an example here. In this case, what we're doing is we're calculating the 90th percentile of request durations over the last 10 minutes. And what we're doing this is defining the histogram quantile, and then we're getting the rate over a 10-minute time frame. So that's going to give us the correct calculation for this use case. There's a lot of great resources out there because Prometheus is such an awesome open source tool. So if you go to something like Prom Labs, it's going to give you a cheat sheet in this resource, various functions and what they do. There's also something called samber.github.io that breaks down a bunch of amazing alerts that you can configure, and it gives you the queries for them. So if you're running something like Kubernetes, Nomad, or maybe you want to monitor something like a Redis database or a MongoDB, right? It gives you the queries for these to be able to use. There's also a ton of great resources on Prometheus's documentation itself, right? So if we scroll up and we look at examples, this is going to give you a lot of the stuff that you want to be monitoring. And then Logs.io also provides a lot of great out-of-the-box dashboards and queries that you can copy. So if you ever want to look at something and you are curious how to build it, what you can do is go into the dashboards, go into the Logs.io dashboards. We have a bunch of default ones, but maybe you want to know how to calculate the pod phase or the pod CPU utilization. What you can do is go into edit and then look at these and start to break them down. ChatGPT is a great resource to explain queries to you. However, sometimes they can provide incorrect values or incorrect calculations, so definitely be careful there. I did create a video on dashboarding in Grafana as well as the Alert Manager. So if you want to pair what you've learned here with the Alert Manager or dashboards, go ahead and give that a watch. I'll link it above, and I will see you guys in the next session.